Okay, welcome back to the basic Python course. This is session 4 about conditions. And before we go into the details about how conditions are realized and implemented in Python, let's again have a thematic introduction before. So the programs that we have written so far are still all linear programs in the sense that they consist of a sequence of statements which are worked off one after another. And we have seen that we can already make our programs quite interactive by querying user input and integrating this user input into the output that the program generates. But the programs that we are writing are still linear in the sense that there's just one direction in which they are heading. What we're doing today is learn how to bring some branching structure into our programs. So if you remember the first session, you might recall that I suggested you to understand computer programs as cooking recipes, in a sense that cooking recipes also consist of sets of instructions which are blindly worked off one after another. In the computer program, we're doing nothing different. Now, the branching structure is also applicable to the cooking recipe metaphor. If you, for example, have a recipe for a cake, there may be a distinction in the recipe if you have butter or if you have margarine. If you have butter, you might use a different number of eggs, or if you have margarine, you might use a different amount of water. And so bringing your computer program into different directions is what's realized with conditional statements, which we will get to learn today. Control statements are, unlike the commands that we have seen so far, are statements that do not produce something on their own, but instead they control other statements, or they control when other statements are run. An example for this is conditional statements, and this will be our topic for today. Today we want to work towards a certain objective, which will consist in a computer program that we want to have written by the end of today's session. And before I introduce you to this objective, I have to say something about David Hasselhoff. So here are 3 fun facts about David Hasselhoff. David Hasselhoff starred in the TV series Baywatch alongside with Pamela Anderson. He helped to tear down the Berlin Wall by singing his song, I've Been Looking for Freedom. And he was once filmed while lying on the floor drunk and eating a hamburger, I believe. So now you know who David Hasselhoff is, and now we come to our objective. Our objective is to write the following program. It should be called pof.py, so a Python script, and it should first ask the user to enter their name and surname. And then when the user has done that, find one interesting thing to say about the user's name. If the user is called David Hasselhoff, ask, are you the David Hasselhoff? If they say yes, say, wow. If they say no, say, well, that is quite a coincidence that you have the same name. Otherwise, if at least their surname is Hasselhoff, ask, any relation to David Hasselhoff? If they say yes, say, wow. If they say no, say, you never know, you might be related to David Hasselhoff. Otherwise, if at least their initials are DH, say, you have the same initials as David Hasselhoff. Otherwise, if all of the above is not true, but the first name is a variant of David, such as Dave, Davy, David, say your name is a bit like David, as in David Hesser. Or if all of the above are not fulfilled, as a last resort, say, I suppose you could change your name to something more interesting, like David Hesser. So I hope it's clear to everybody what the task here is, what the objective is that we want to achieve, or what the program is supposed to do that we are writing today. And before we start, I want to make a final note on programming. So in the beginning of the of today's session, we will again be working on the console. And when you're working on the console, this is for the purpose of exploring, testing, and debugging. So trying to find out what certain commands produce in order to understand how you have to integrate them into your script. But this is not actual programming. Yeah? This is just exploring, testing, and debugging. In contrast to that, when we're writing an actual script in the editor, this will be developing an actual program. And other than in the last sessions where we learned a lot of things about data types and sequences and mappings, we will today write an actual program and not just work on the console. So I'm going to change to Spider right now. So this is the Spider IDE with the editor on the left and our console on the bottom right. And before we deal with conditions and see how we can implement conditional statements, we have to talk a bit about Boolean variables. We've already seen Boolean variables in our, I think, second session about variables and data types. And Boolean variables are basically the logical data type of Python, which can be characterized by a yes-no question. So a question that can only be answered yes or no. And as such, Boolean variables can only take two possible values, which are true and false. As an example, if I define x to be 2, y to be 3, and z to be 7, I can use those variables to create logical statements. For example, I can write down the statement that x is larger than y. And if we look at the values, this is not the case. So the result of this is false. On the other hand, if we ask whether x is greater than or equal to 2, then this is true because x is equal to 2, and as such, it's greater than or equal to 2. So here we get true as the value of this Boolean variable. We can also combine two of these comparison operators, for example, by writing 0 smaller than x smaller than or equal to z. And because x is between 0 and 7, the result of this is also true. So to summarize, you can use smaller than, greater than, smaller than or equal to, and greater than or equal to compare numerical values, which will then result in logical statements that are evaluated as either true or false. If we want to check that two things are equal, we can obviously not use x equal to y. Why can't we use that? Because we've learned that x equal to y is a variable assignment. So that means take whatever is left, whatever is right on the equation sign, calculate or compute it, and then submit it to the variable name on the left side of the equation sign. And this would write the value 3 into the variable x, which is not what we want. We want to actually compare x with y. And for that, in order to escape the problem of variable assignments, you typically use double equation sign. So if we type x equal y, this would mean that we want to check whether x and y are equal, and they are not. So this is false. On the other hand, if I ask whether x is equal to 2, that is true. So once again, the single equation sign is used for variable assignments in Python, and the double equation sign is used for checking whether two things are identical. This, by the way, also works for strings. So if I define two strings, name 1 and name 2, and they have exactly the same value, I can ask whether name 1 is equal to name 2, and the result of this will be true because they are exactly the same string. Here, watch out for a few traps, because first, string comparison is case sensitive, and second, non-printable characters such as spaces are also counting as characters. This means that if I compare name 1 to David Hasselhoff in non-capital letters, this would evaluate to false, simply because strings are not spoken words, but they are sequences of characters. And the lowercase d is a different character than the uppercase d. And same for lowercase h and uppercase h. Similarly, if I compare name 1 to David Hasselhoff, but there are a few strings at the end of this string, the result is also false, because these are not the same strings. The string on the right-hand side has 3 spaces at the end, which the first one does not have. So these strings are not identical sequences of characters. In addition to like asking whether something is greater than or smaller than or equal to, one can also combine single logical statements. For example, I can ask whether 2 plus 2 equals 4 or 1 is greater to 2. Now it's clear that 1 is greater to 2 is false, but 2 plus 2 equals 4 is true. And if you recall your philosophy or logic seminar, you will know that a logical OR is true if one of their segments is fulfilled, and in this case, 2 plus 2 equals 4 is true, which is why the whole thing is also true. On the other hand, if we combine these two statements with AND, they are not true, because the logical AND is only outputs true if both of the statements combined are true. And this is not the case here, because 1 is not greater than 2. So this will be false. You can also use not. For example, if you ask whether 2 plus 2 equals 4 is not the case, this would be written in this way. And since the statement is true, its negation is false, and it is not the case that 2 plus 2 equals 4, which is why here we get false. Just like in mathematics, using parentheses is recommended. So we have seen that these statements worked, but for greater clarity and in order not to run into unexpected mistakes, it is recommended to use parentheses around those logical statements to make them work better. Same can be used in the case with the not. And Python actually has an abbreviation for not together with equal, so check. checking for equality, which is exclamation mark equal. In other words, the one in 18 that is asking whether it's not the case that 2 plus 2 plus 4 can also be expressed like this, 2 plus 2 exclamation mark equal to 4. And with that, we would ask whether 2 plus 2 is unequal to 4. And it's of course false, so we get false as an output. Okay, so this covers the very basics of logical statements in Python. And um, now we need to discuss one more thing because before we can write our first if statements or conditional statements, which is that you remember that I told you that the type designators in Python, such as str for string, or int for integers, or float, or list, can be used for converting variables to this data type. Now, the same is obviously true for Boolean variables. So if I ask for the type of this, it's a bool variable, which means that I can use bool as a type conversion function for converting things to Boolean. Now, let's try out strings. What happens, for example, if I convert this string? Python is a terrible programming language to Boolean. I hit enter and I get true. That seems quite right, but let's also try the inverse of that, or at least a statement which is incompatible with that. Always perform your negative checks. Python is an excellent programming language. And that is also true. And that, of course, can't be quite right. Well, the reason behind this is that Python, of course, doesn't have world knowledge. It cannot really evaluate the truth values of statements which we input as strings. And therefore, it uses just a single, very simple rule, which is that all non-empty strings evaluate to true, and only the empty string evaluates to false. So there's just a single string that generates a false Boolean value, which is the empty string containing a single character. If we now summarize this as empty strings become false, non-empty strings become true, we can ask ourselves whether the same case is true for lists. And this is actually the case. So if we use our well-known shopping list, eggs, bacon, pudding, and so on, you see that if I have a non-empty list, this evaluates to true. On the other hand, if I convert an empty list to Boolean, this will be false. Now, if this gives us the rule of thumb that non-empty things become true and empty things become false, what about numbers? Which number could be considered the empty number? Well, that's not hard to guess. It's, of course, the 0, which means that 0 converted to Boolean is false, and any other number, no matter whether it's an integer, a natural number, or an integer, or even a floating point variable, converts to logical true in Python. So that's it for the moment when it comes to how to create logical statements and how to convert other variable types to truth values, either true or false. And with that, we can actually start to edit our program. So I've here clicked File and New File, and then there's this new file in the editor, which has opened, and we can actually start writing the program. If we go back to the objective, we saw that the program should at first ask the user to enter their name and surname. So that's what we're going to start with. We say input, what is your name and surname? Question mark, space, make the prompt look a bit nicer. And we're going to write this, whatever the user inputs, into the variable username. Now we can use this variable and perform the first check of our program, which is to ask whether the username is equal, remember here I need 2 equation marks, to the string David Hasselhoff, which is the name which we are after. Then I put colon, and then I hit enter, and the next line is automatically indented. I will say a few things about this in a moment. And then I hit print, and are you the Hoff? Okay. I'm going to save this as hoff.py. And now we're going to run it and try whether it works. What is your name and surname? David Hasselhoff. And we are being asked, or we get the user output, are you the Hoff? Which indicates that our input has triggered this if statement, and we ended up executing this command. Let's, of course, also perform the negative check. What is your name and surname? Let's see what happens if I enter my own name. In this case, no question, are you the Hoff? So everything seems to be quite right. So here's the general syntax for if statements in Python. Write if, this is a reserved word, it has to be exactly like this, cannot be something else. Then write some logical statement, some condition, which can either be true or false. Then write colon, then integrate a line break, indent by 4 characters in this case, and type the commands that you want to be executed under the condition that your logical statement is true, is found to be true. Okay, now coming to this indentation. First of all, indentation is important. Yeah? Without indentation, our program wouldn't work. So if I, for example, run this like this, we get an indentation error. Python expected an indented block simply because we used a control statement if username equal to David Hasselhoff, and we haven't provided indented statements which are always supposed to follow such a control statement. Similarly, if I add a second line below this one, the really real Hoff, and I use different different amount of indentation, I also get an indentation error which says unindent of this line 12 does not match any outer indentation level. So here we are on level 1 of the program. Then we're going one level down. And here we are supposed to either stay in this level or go back to the original level, level 1, but we are doing neither of this. So this is again an indentation error. Now observe what happens if I put this print command here versus here. If I run it like this and enter David Hasselhoff, it asks me, are you the Hoff and the really real Hoff? Which is quite correct. Now, consider this version of the program. If I run the program and enter David Hasselhoff, I'm being asked, are you the Hoff, the really real Hoff? And everything seems quite right. But if I now rerun the program and enter my own name, I'm also getting the question, the really real Hoff. And this is an example for a program which is syntactically correct, so we don't get an indentation error, but it's semantically not correct because I shouldn't be asked the really real Hoff if my name is not David Hasselhoff. And the reason for this is that the end of the indentation, which is here after line 11, marks the end of the control statement's influence. Yeah. So wherever you use indentation, you're telling Python to subsume this under the control statement, for example, this is if clause, and only run it if this if statement is true. However, if you switch back from indentation to non-indentation, you are back again at level 1 of the program and in the linear structure, and this line is being run regardless of whether the logical statement is found to be true or false. As a hint, I would suggest to always use one empty line before and one empty line after such a control statement, just for the clarity of the program and better readability. It helps a lot to kind of structure your program in that way, and also helps you to see where the influence of a control statement ends if you deliberately include this empty lines. Okay, so what are the most common errors with if statements? So in case you are getting an error after you have written an if statements, you have most likely done one of three following things. Either you have forgotten the colon at the end of the statement, otherwise Python doesn't know that's a control statement. Second could be that you have used a single equation sign where you meant to use double equation sign, because remember, single equation sign means variable assignment and double equation sign means check for equality. Or third, another problem might be that you have simply forgotten to indent the commands that you want to be executed in case that the logical statement is true. And in this case, do the proper indentation, which here should be like this. So this is our program in a very early state. Now, in order to add the other checks or requirements that we are supposed to do with our program, we'll need a few more control statements. So let's go back to our objective, which was like this. It says, if they're called David Hasselhoff, ask, are you the David Hasselhoff? And so on and so forth. We'll come to this in a minute. And then it says, else if their surname is Hasselhoff. And luckily, the structure of this in Python is very similar to the structure of this in the English language. So I can simply, after an else if, after an if type elif. Elif in Python is the abbreviation for else if, and it's always being run under the condition that all the if statements above those control statements have been found to be false. Okay, so here it should say something like user last name equal to Hasselhoff. And in this case, we should ask, the program should ask, sorry, are you related to the David Hasselhoff? Okay, but our program will obviously fail because we haven't defined user last name so far. Okay, so how can we do that? I'm not sure whether I have introduced you to the method, to the string method split, but what the string method split can do is can split strings using the empty space as delimiters. So we can see here in the variable explorer that username has the value Joram Sacher at the moment. And if I split this, I get a list of two strings because there's one space in this larger string. A list of two strings, which are my first name and my last name separately. So we can here add the command usernames equal to username split, in which case we would have a list consisting of two entries. Supposedly, if the user enters exactly one first name and exactly one surname, and how do we then get the first name and the last name? Well, just remember list indexing in Python. You can simply call usernames and then 0. This would be the first element in the list. And usernames 1 would be the second element in the list. And let's submit this to variable names user first name and user last name. And here also putting the equation signs one after another to make it look a bit tidy and clean. Finally, we can immediately use this to also generate the initials because those individual entries of the list are strings. And strings itself are indexable, as we have learned. So if we want to get the first letter from a string, we simply call this string, user first name, with the index 0. And this will give us the first letter from the first name. And this will give us the first letter from the last name. How do we combine them? Well, because we use plus. So we have learned that plus is good for concatenating strings, and single letters, single characters are also strings, and therefore we can concatenate this two to come up with the initials. Let's run our program with David Hasselhoff as input first and check in the variable explorer whether everything works as intended. So we have user first name David, user last name Hasselhoff, and user initials DH. Great. So then let's also add our third check or third requirement program, which is to ask for the user initials. And if the user initials are DH, it should say you have the same initials as David Hasselhoff. What a coincidence. Okay, great. So now one question. You can pause the video if you want to make up your mind about this question. What happens if I now run the program and enter the name Diana Hasselhoff? Okay, here's the solution. It will, of course, trigger the output, are you related to the David Hasselhoff? Because this one is found to be false. The name is not exactly David Hasselhoff, but the first one after that is found to be true because the last name is equal to Hasselhoff, in which case the response should be like this. At this point, let's also add the final else to our program. So the final else does not have a logical statement because it means something like otherwise or if all of the above is not true, if all of the above is false. And in this case, the response should be, I suppose you could change your name to something more interesting, like David Hasselhoff. Great. So here we have a pretty skeletal version of our program in a sense that we are already asking for a few checks, but not all of them, because now we have to get to nested conditions. So have a look at the structure of the program. So what we have not realized so far are these black square bullet points here. So if they're called David Hasselhoff, um, the program should ask, are you the David Hasselhoff? And we are already printing this as output, but we are not really gathering the answer to that from the user. Well, the way to do this is that, of course, we need another input command, but where does this input command has to be put? Well, the answer to this is that it needs to be indented. Everything that comes now needs to be indented. Let's ask input. Are you the David Hasselhoff? And let's write the result of this query into a variable called if is Hoff. And now, importantly, the next if statement has to be indented as well because it's a nested condition. It should only be checked if the username has already been found to be exactly David Hasselhoff. If it is yes, it should say wow, else should say well, that is quite a coincidence that you have the same name. Indeed, what a coincidence. So, one more time, if I didn't indent this, there's even a command here in the editor menu. If I unindented this, we would, of course, get an error because um, we have already used else here, and after the else, we cannot use another else if. So else always marks the end of such a if then else chain. And this also means that else can only occur once in each of those checks. So let's indent this once again and do the check whether it works. In order to be able to check that, we of course have to enter David Hasselhoff. So let's first see what happens if I enter my own name. Okay, I don't fulfill any of the conditions. So let's enter David Hasselhoff, and then we're getting the second question. There's space missing here. And we answer yes. And it says wow. Try once again. And this time we ask, we answer no, no, no. And then we get the other output. Well, that is quite a coincidence that you have the same name. So here, once again, consider another print statement. That's amazing. Placed, for example, here. And if we move this to here, it's not under the influence of the control statement in line in line 17 and line 19. So if we enter this if clause by typing David Hasselhoff and then enter something, the line that is amazing will be printed regardless of our of whether our answer will be yes or whether it will not be yes. Okay, so now that we have reiterated this point, I want to again give you one more hint how to understand those conditions and nested conditions. So say we have a bullet point. This is a bullet point. And then this is another bullet point. And then obviously we can have sub bullet points. For that sub point, and then there's a sub point, and after the sub point, there's sub point 2. So this bullet point sub point 2 thematically belongs to this major bullet point. This is a bullet point, but it doesn't belong to this other one. This is another bullet point. Similarly, sub point thematically belongs to the sub point and to this is a bullet point, but not to sub point 2. Yeah, and you can understand control statements and nested control statements in much the same way. That is opening up such a hierarchy of bullet points or questions or checks, and some of these checks are only being performed if other checks have already been found to be true. Okay, great. Now let's have a final look at our objective. And we see that there's one more thing that we have to add. No, actually, there's two more things, but one more thing. Else, if their first name is a variant of David, such as Dave, Davy, or David, say your name is a bit like David, as in David. So let's very naively just try to write this down. If user first, sorry, else if user first name, we have already extracted this on top using the string method split, is equal to Dave. or Davy or David. Say your name is a bit like David, as in David Hasselhoff. Great. So what happens if I run the program with the input Dilbert Hoffelhass? Once again, you can try to make up your mind about what the solution is. Well, of course, you have the same initials as David Hasselhoff. Okay, now let's try to enter a name such that we enter this line or this control statement here. So let's, for example, say that my name is Dave Gotthard. So if our reasoning is correct, in this case, line 28 should be triggered, and we should get the output. Your name is a bit like David, as in David Hasselhoff. Very nice. Let's see whether this also works with Davy Gotthard. And let's see whether it works with David Gotthard. Very strange names here. And yes, it works. But don't forget the negative check. Negative check in this case would be my name is Jane Gotthard. So no initials DH, no user last name Gotthard, and this time also no user first name, which is similar to David. And we still get the output. Your name is a bit like David, as in David has. So this can't be quite right. What is the problem here? So sometimes it helps to like just copy this line from the script and evaluate it at the console. If we evaluate this logical statement at the console, we find that it is Davy, very strangely. And if Python in control statements finds something which is not a Boolean variable, it automatically converts this to Boolean variable. And if you remember what we have learned about conversion to Boolean, we've learned that every non-empty thing resides in true, and because Davy is a non-empty string, we get a truth value here, which in other words means that every first name, no matter what it will be, will trigger this condition. Very unfortunate. So what is the reason behind this? First of all, this is a program malfunction without an error. Yeah. So the program runs smoothly and you yourself have to see that something is wrong. Those errors are very hard to diagnose, but we have to diagnose them. So the reason for this is that the OR operator in Python doesn't work like the OR in ordinary language. In ordinary language, we can say something like, if your first name is Dave or Davy or David. In Python language, we cannot say it like this because their OR statements are introduced or understood in another way. Here, An or statement means something like look to the left of the or and evaluate it and see whether it's true. Then look to the right of the or and see or evaluate whether it's true. And in order to come up with a proper solution, what we need to do is provide complete logical statements for each element of the or. So we need to put user first name equal to Dave, equal to Davy, or equal to David. And in this case, the input chain has does not anymore trigger the output, your name is a bit like David, but we in fact get the correct output, which is, I suppose you could change your name to something more interesting. Okay, so I'm going to keep this here as a comment, as a wrong version. And I'm going to add this again to come up with the correct version. And there's another way of writing this, because in Python there exists the in keyword. So, for example, you can ask whether user first name is in, and then you provide a list of values. And this would ask whether the variable on the left of the in is equal to any of the elements in the list, which in this case it is not. But if we redefine our user first name to be Davy, then this statement would trigger true, which means that we can add this here as another correct variant of our program. Let's try it once more. I'm going to enter my name. And my name is not special in the sense of this program. It doesn't trigger any of the conditions. So we end up with the last resort, which is, I suppose you could change your name to something more interesting, like David Hesse. Okay, fine. You can now take a few minutes to you can now pause the video and take a few minutes to complete the program. There's one last thing in my eyes which you have to do, namely implement this nested condition under the surname check. So if that is the case, ask any relation to David Hasselhoff. Then if the answer is yes, say wow. If the answer is no, say you never know, you might be. So I'm going to make a jump now and show you the finished path.py program. And here I've also added and here I've also added extensive comments to the code, which is good practice in coding, as I already said, and which will also be a grading criteria in the exam for this course. So always provide a doc string to your program, which clearly states the purpose of the script, and then add inline comments like this one or even this one, which clarify the role of your commands and why you did what you did. It's not just for other users of your program, it's also for the future you to understand why you wrote the program in the way you wrote it. So this is the final program. I will upload this to the Moodle, and then you can have further look on it, and you can use it as the basis for the first exercise, I guess. Before you do the homework, I invite you to have a look at this section on handling errors. So here you can learn how to use another sort of control statement called try except error to like catch non-fatal errors in your program and to then come up with exceptions. That is, things that should be done in case that such an error occurs. This prevents your program from breaking in the case that such an error can be anticipated. And please have a look at this section because it will become relevant later on. And then have a look at the exercises. The first one consists in refactoring the Hoff program, so making it a bit more general. And the second exercise is about writing a completely new program, performing completely different checks and querying user input multiple times. When you start this homework, I would invite you to have a look at this Programmablaufplan or program structure plan, in English sometimes also called flowchart. So these are the kind of segments that you can use here, start and stop, with some rectangle with round edges, and then input and output would be designated as, would be denoted by parallelograms, and each if clause resulting in the branching of a program would be realized or would be denoted using such a diamond symbol. If you write down the structure of a program, it may then look like this. Of course, our David has a program, and program in exercise 2 is much more complex. But I think that's a great way of clearing your mind and finding out about what exact structure the program or the task that you should fulfill has, and what should come first, what should come second, which check should be nested within another check, and so on and so forth. Okay, with that, I wanna thank you for your attention and see you next week. Please enjoy the other videos.